Welcome to another lesson of Academic Insights Chemistry Tuitions. So today we'll be covering part 2 of the topic of organic chemistry. In the last lecture, we covered part 1, which was strictly involved into the introductory part of organic chemistry. We also managed to tackle a subtopic of alkanes in part 1 of that lecture. So as for today, we'll move on to part 2, where we'll look strictly at isomerism, specifically isomerism in alkanes. So you can get a book and a pen and prepare to take out some important points. So isomers, by definition, are simply compounds with the same molecular formula but different structures. An example is when we have butane, for example. Butane, the formula is C4. If you remember first the general formula, it was CnH2n plus 2. So but simply refers to 4 carbon atoms. So it will be C4H2 times 4, that is 8 plus 2 H10. So the formula for butane is C4H10. And you strictly noted out the structure of butane. So imagine we have a compound of butane drawn with a structure which we looked at in the previous video. We may also have another structure of butane, but drawn different from the one which we looked at. So though they may have the same molecular formula, they may exist in different structures. You can draw them differently. So that's what we mean by the term isomers, which are compounds with the same molecular formula but different structures. These isomers are differentiated from isomerism. When we talk about isomerism, we simply relate to the existence of a compound. Now this existence is such that the compounds are existing with the same molecular formula but different structures. So that's the major difference between isomers and isomerism. We can also define isomers as compounds with the same number of atoms of each element but different structural formula. This also qualifies to be correct because when we look at molecular formula, the definition of the molecular formula, it shows simply how many atoms are in each element. We may have C